Hello everyone. So this is another MATHCOUNTS problem. So this is a workout problem. So I'm gonna use a calculator if I need to, because I think I will need that as well. Okay. So we are looking for the tens digit of this number. Okay. So if you are not familiar with the mod, that might be a bit challenging question, but it's basically you are gonna take the remainder. Okay. So we have 17 and we'd like to find the 17 as a base, and we'd like to find the 10th digit of this huge number, okay, which is like, if you are looking for usually the last digit, we just take the mod 10, because if you divide a number by 10, the last digit is actually your remainder. But now we are looking for the 10th digit, so which is why we want to find the mod 100, okay? So it's basically 17 to the 1993 is going to be equal to a number mod 100. So the meaning of this, when you divide this huge number by 100, x is going to be your remainder, okay? Might be one digit or two digit. So whenever you are looking for the remainder, we just like to find some sort of pattern, okay? So to do so, we just need to start with at least power of 17s and start with the lowest one. So 17 to the 0th power. Actually, we don't need that. So the first power is just 17. So if you divide by 100, so the 17 is going to be remainder, okay? And 17 to the second is, I'm going to say this is actually congruency. When you divide this by 100, so it's called 17 mod 100. And then if you take this 17 squared, which is 289, right? So 289, if you divide this by 100, so your remainder will be just 89, okay, mod 100. So if you take the third power, so you are multiplying the second power by the first power to get the third power, or you could just multiply 17 by 89, so 17 times 89, and that would be 1513, but that will be just 13 when you take mod 100, okay? So I'm not gonna write those mods anymore, so you just know what I'm talking right now. These are not equal, these are just congruent to each other. So 17 to the 4th power is gonna be, you are gonna multiply 17 to the 3rd by 17 to the 1st to get 17 to the 4th power. You basically multiply 17 by 13, okay? So 17 by 13. If you do so, you actually get 221. And if you take the mod 100, so that would be 21. Okay, so that is actually something useful. But you may continue doing this because, like, we didn't get the one right here, but at the same time, we do have 1 as my last digit. So whenever you actually have a 01 instead of 21, then you can take any power of that 01 to get also 01, okay? But now we don't really have that 01. I'm not sure if this is going to be possible to get 01 anyway sooner. So which is why instead of taking the 5th power, I'm going to actually take the advantage of this 1 at the end. So I'm going to multiply this 17 to the 4th, okay, by 17 to the 4th, which is going to be 21 times 21, which is 441. That is actually 41 if you take mod 100. Okay, this is still okay, but this is a 1. Maybe I can take, this is 17 to the 8th power. So 17 to the 8th, and I can multiply this by itself. So that will be 41 times 41. Okay, and if I do this, 17 to the 8th power, so we know this is basically 7 to the 8 was 41. So if you multiply 41 by 41, so let's go ahead and multiply. Actually, I don't really know that number. So you can just use a calculator or just multiply 41 by 41. But I'm going to use this as 40 plus 1 to the 2nd power. I'm going to use the square root binomial. So that is 40 squared plus 2 times 40 times 1 plus 1 squared. That's 1600 and plus 80 plus 1. So that is 16 181. And if you take mod 100, so that will be 81. Okay, so this is still good, but the last digit are still 1, so it's kind of helpful to maybe continue doing some similar stuff. I can multiply 17 to the, this is 16 power. I'm going to multiply this by 17 to the 4th power. So that was 17 to the 20th. And 17 to the 16th power was 81. And the 4th power was 21. Okay, so these are actually congruent to each other. And then if you multiply 21 by 81, you do get 1701, which is really nice because if you take mod 100, that is actually equal to 01, which is useful. So which means when you take the power of 17 after 20th power, you are actually going to get the same cycle of 20 remainder. Okay, so you could just now go back to this number. Okay, so I can say 17 to the 1993, like 1980 is actually a multiple of 20, right? So I can say 17 to the 1980 times 17 to the 13. And this guy, 17 to the 1980, I can maybe divide by 20. So if I do this, I will get, I guess, 99, right? So divided by this by 2. So that should be 9. That's 18. So that will be 9. So times 17 to the 10 times 17 to the 3rd power. So I'm going to take the mod 100. So, this guy was 17 to the 20th power is 01. So 01 to the 1990 power times 17 to the 10th power. Actually, I do know 12th power, right? So I do know 8th power was something like this. So maybe it's easier to deal with the 12th power. So I'll do that way. So I can do this 12th power times 17 to the 1st. So 12th power is, the 4th power was 21. And then 8th power was 41. Okay, so if you do multiply this, or you can just do it separately, the 4th power is 21. Maybe it's good to see those separately as well. So I can write 17 to the 8 times 17 to the 4 times 17 to the 1st. So this guy is 8th power, which is, we already know, 41. And the 4th power was 21. And 17 to the 1st, just 71. So this is just 1. 01 to the 99 is just 1. And you have 41, 21, and 17. So you can just go ahead and multiply these with a calculator or just multiply any two. So if you multiply 41, 21, which is, I guess, we see. So that will be, this guy will be 861 times 17. So if you take the mod 100, that's 61. So again, these are all congruent to each other. Okay, so that will be congruent to, and times 17. And I just didn't write mod 100, but you can just add it just to sake of writing those mathematically correct statements. Okay, now if you multiply 61 by 17, so you do get, this guy will be 1037. So if you take mod 100, so that would be 37 mod 100. What is that supposed to mean? So your remainder is 37 when you divide this guy by 100. So your last two digits is 3 and 7. But the question was asking the 10th digit. The 10th digit is just 3. So the answer is this number. Again, it's not really too complicated problem. Only thing is actually challenging with this problem was the number wasn't really that nicer to get the 1 when you take the power of those 17s. Okay, but this is a workout problem, so you can use a calculator to multiply those things. So which is why it's not really bad actually. But we are looking for the 10th digit. So a couple of reminders. So we usually see the last digit or unit digit, which is we take mod 10. But in this case, we are looking for the 10th digit, and then we are looking for that digit itself. So that's just 3. Some people go with 37. So that's also dangerous. You do all these work and then get 37 as your answer, which is not the case. And that's your second reminder. And if you like to use something else other than this modular arithmetic, so you may use binomial theorem as well, which is, I'm going to leave that option to try if you have some idea about the binomial as well. Okay. So anyway, so this is it for this video. I'll see you next time.